Alright, so we're going to finish up this section of the note sheet with the definitions. Now, earlier we looked at rock types and the principles of relative dating. We're going to finish up here with the definitions. These definitions aren't so much going to be an explanation of what you see, but putting a label on what you see. You use the principles to explain what you see and to support your argument if you and someone else disagree about what kind of rock sequence you're looking at. So the first definition is conformable. Conformable rock layers are deposited in sequence with no interruption. The base here is conform. If something conforms to society, it fits in. Something conforms to a shape, it takes on the shape. So conformable rock layers are just what you would expect. They're deposited in sequence from bottom to top with no interruption. Basically, no erosion, no drama. If we were to draw a basic conformable sequence, let's say we have 3 layers. The bottom is shale. Above that we have some sandstone. And on top we have some limestone. So it's conformable. The oldest is on the bottom, the youngest is on top. No drama there. Now it's important to note that on the whole planet, we don't find conformable continuous layers. The reason we don't find conformable and continuous layers anywhere on the planet is because we have active plate tectonics. We have active weathering and erosion. So everywhere you go on the planet, you'll find some disruption. You won't find continuous history from 4.5 billion years until now. But if you travel around the planet enough, you can find pieces of the Earth's history. So maybe if you go up to Canada, you'll find rocks that are 4 billion years old. If you head down to Florida, you'll find rocks that are 10,000 years old. So different places on the planet will have conformable sequences. But no place on the planet has continuous all the way from the beginning of time to now. And this is due to plate tectonics, weathering, erosion, and just basic disruption by humans and animals, and mass wasting. So all of those will make it so you don't find conformable continuous. Now the next on our list is kind of the opposite, unconformable. Unconformable is a surface that represents a break in the rock record. Deposition stopped, a period of erosion wore away layers before deposition. So imagine the same sequence as before. Our shale got laid down. But then before the sandstone, there was a time of erosion where some of the story got erased. And then the sand piled up, became lithified to be sandstone, and then eventually our limestone on top. That wavy line there, that's erosion. Erosion is an unconformity. So it's the opposite. Conformable means no erosion, no disruption. Unconformable means there's been some drama, some erosion wore away. Could have wore away the whole layer or just part of it, but there was definitely a break in the rock record. And so sometimes you hear people say, hey, what's unconformable? A break in the rock record. Sometimes people say, what's unconformable? Others will say, erosion. Now, deposition always happens underwater. I'll use green. That's where all our sediments are laid down to form sandstone, limestone, shale, and conglomerate. And the erosion happens on land. So erosion happens during a time where sea level drops. Deposition happens during a time when sea level is high. Then the next three are all types of unconformity. So C, D, and E are all unconformity subtypes. Or I like to call them three flavors of unconformity. So if you see some erosion, you know it's unconformable, then you have to decide what type it is. The first one is called an angular unconformity. So an angular unconformity means that your layers are tilted or folded, and then they're overlain by flat-laying strata or layers. So if we took this original sequence, and maybe through plate tectonics there was some compression, and they got tilted. Now our shale is still technically at the bottom, our sandstone on top of that, our limestone on top of that. But then, if there was a time of erosion, right there, then something new could form. And in this case, since I haven't used it yet, I'm going to use conglomerate. So the order here would be oldest is shale, then sandstone, then limestone. The whole thing got tilted due to the principle of original horizontality. Then erosion, and then the conglomerate forms. The next on our list is a disconformity. A disconformity, the layers are all horizontal. It's difficult to distinguish as an eroded layer at all. It is tricky. And you notice this is the most common of the unconformities. The reason it's tricky is because the erosion is hidden. When I was a kid, if someone kind of made you feel bad, you could say they were dissing you. Recently, people use words like, oh, treating your life, or treated, fry, burn. There's all kinds of different ways to say that somebody made you look dumb, but in my day it was diss. So when I think of a disconformity, I think, oh, this is making me look dumb. I didn't even know the layer was missing. If we were to walk upon a disconformity from this sequence, we would have our shale. And there may be a slight obvious erosion line, but probably it's going to fit right in between two layers. And now we have that limestone. And above that, we'll put our conglomerate. So if the only box I ever saw was this one, I would think, oh, that's the whole story. But if I walked down the road a bit, I would see, hey, there's usually sandstone in between the limestone and shale. What's going on? Oh, the erosion's hitting. The whole layer has been erased. Now, in the case of trying to figure out what kind of unconformity you're looking at, with your angular unconformity, they're all angled underneath the erosion. With your disconformity, they're all horizontal under the erosion. The last one is a non-conformity. It's non-sedimentary. Underneath the erosion, we have a completely different type of rock, either igneous or metamorphic. So maybe once upon a time, we had some igneous rock that had formed, crystallized completely, and then got eroded. And then the rest of our story happened just as you would expect, with our shale, our sandstone, and our limestone. So in this case, this is a non-conformity, because under the erosion line is non-sedimentary rock. It's either igneous or metamorphic. I used igneous, could have been metamorphic, no big deal there. In all three cases, the unconformity is the erosion line. We just have to figure out what's going on beneath the erosion to figure out what type of unconformity we're looking at.